students, welcome to the heat transfer laboratory. I am here to present an experiment on air conditioning system. So here we have an air duct representing the air conditioning system. So in the air conditioning system we have different components which are situated here. Right at the inlet we have two temperatures. One is a dry bulb temperature, the other one is a wet bulb temperature indicator, thermometers. And after this we have next a heating coil which is connected to electric power. So we are going to operate this by switching on the right type of switch, heater, to make it function. And after this heater we have the next component here which is called as evaporative or evaporator coil, which is cooling coil in other words. And this cooling coil is connected to the refrigeration cycle which is situated at the base, and then followed by this we have next another heater. Again we have switch on coil, switch on switch here to operate this, and towards the one end we have evaporator fan in order to facilitate a positive flow of the air through the duct. And at the outlet we have again two more thermometers, one indicating the dry bulb temperature, the other one is indicating the wet bulb temperature. Purpose of air conditioning is basically for the comfort use. Therefore for comfort purpose, temperature of around 22 to 25 degrees Celsius is desired, and at the same time relative humidity of around 40% to 60% is desired. Now in order to treat the air, in order to suit our requirement, we have different components here. So in these experiments we are going to look at basically three parameters. One is the sensible heating process, second one is sensible cooling process, and the third one is cooling and humidification process. In case of sensible heating process, what we see here is the air from the ambient will be drawn through the duct, and as it flows through the duct, heater 1 will be on. So at this point the atmospheric air is going to get heated up, and then we see that the air is going to flow over the duct and it flows through the outlet. So at the inlet and at the outlet we are going to make a note of the temperature related to dry bulb temperature and the wet bulb temperature, and we are going to locate these state points in the psychrometric chart, and then we trace out what is the relative humidity value and the corresponding specific volume values. So that is about the heating process. Followed by that we have next the sensible cooling process. In the sensible cooling process, again air from the ambient will be drawn through the duct and it flows over the cooling coil. So here we have a cooling coil which is connected to the refrigeration cycle, and we know that refrigeration cycle has four important components: evaporator, which is representing here the cooling coil, followed by a compressor, and then heat exchanger and the expansion valve. So at the compressor, again we make a note of the inlet and outlet temperatures, and these temperatures can be made note from the panel. So here we have a switch through which one can make a note of temperature T1 at the inlet of the compressor and temperature T2 at the exit of the compressor, and then we have temperature T3 which is the exit of condenser, which is a heat exchanger basically, and then we have a T4 which is the exit of the expansion valve. So here we have an expansion valve, and we have two modes of expansion here. One is a capillary mode, the other one is solenoid mode, and then at the outlet of this the temperature is made a note. Beyond this we also have a provision for making a note of voltage and the current through the voltmeter and ammeter. So through this one can also make a note of the power. So we have energy meter here, so one can find out what is the amount of work input that is going on to power the compressor. So this is about the panel. Once the sample of air going to lose the heat, it becomes cool, and the cool air is going to pass through the outlet. Again, by making a note of the inlet and outlet temperature conditions related to dry bulb thermometer and wet bulb thermometer. Referring to the psychometric chart, one can trace the value of relative humidity and as well as specific volume. And the third process that we have in place here is the cooling and humidification process. In cooling and humidification process, again the air from the ambient is drawn into the duct, inlet temperatures will be made note, and then we have a humidifier at this point. We are going to add moisture to the sample of air, and that moisture will be added through the boiler. We have a boiler here, it is going to make steam, and that steam will be sprayed over the sample of air. So the air is going to get added with the moisture content. And next to that, we have a heater here, it passes through the heater, and then it passes through the outlet. Again, we make note of the temperatures at the outlet. We refer to the psychometric chart and get the value of relative humidity and the specific volume. And by coming back to the evaporator coil, since we are using refrigeration cycle here, vapor compression refrigeration cycle, we are going to calculate coefficient of performance, which is given as refrigeration effect divided by the compressor working rate. So we refer to the refrigerant chart. The refrigerant that we are using here is R22. So we are going to refer to the pH plot in that, and then we make a note of enthalpies at different state points. And by substituting the enthalpies in the equation of coefficient of performance for the refrigerator, we are going to find out the COP value. And one can find out the actual COP value also depending upon the heat that is absorbed to that of compressor input. The heat that is absorbed is calculated based upon MCP/dT equation, and the heat work input that has gone, one can calculate based upon V into I. So that is about the actual COP, and then one can divide the actual divided by theoretical COP and calculate the relative COP as well. So this is how we are going to calculate and find out different parameters of interest related to psychometry processes. So this is all about air conditioning experiment. Thank you.